Welcome back to my channel. Today I would like to talk a little bit about the arc length versus the chord length. I've had some comments saying that you need to take distances on the arc of the length rather than a straight line because it's a different distance. And all I want to do in this video is prove that it really doesn't matter when I'm talking about these 100 mile 200 mile or even 300 mile distances. There's really not that big of a difference in what a straight line would be versus if you take into consideration the curve of the earth and what that arc length would be. So what I want to do is, or what I have done is I've taken some formulas and created a little thing over here that shows me what my arc length is, chord length is, sagitta, degrees and change, depending upon how far away an object is and where I'm standing. So you can see I've taken these different formulas to figure out the sagitta, or the height of the bulge with the arc. This would be considered the arc length. This would be the chord length, sagitta. This is my degree, my angle of what my arc length would be. So you can see I have these different formulas here in my Excel spreadsheet that I've filled out and tied them all together so that I can figure out what all these different things are. So you can see I've got these are my references of the calculations that I'm coming up with. So if you want to look at all these, pause the video, type those in, you can see where I'm coming up with my formulas. So if we go to those, basically I'm looking at the arc length, and if you can change this, you can see what the formula is right here and what those different things are. I've got the sagitta one. You can look that up. And you can actually see my other video that I did on the sagitta. I've already proven what the sagitta is and how to really calculate the curve of the earth and what it really is versus what people use. Using the SAS triangle, which means side, angle, side, to figure out what the other side is, and then also using three-sided triangle to figure out what the angle is. And so once I've got all those figured out, I can then plug those numbers into my formulas here to figure out what the degree is, how far away I am from an object, or if I know how far away I am from an object, what my arc length is, what my angle degree change is, and all that kind of fun stuff. So I'm not going to really explain all this information other than showing you. You can see what I've done. You can see I have formulas in here to calculate all this stuff. They aren't just numbers. There's a lot of formulas that I've done. But the main formula over here I want to talk about is I've taken all of this over here and put a nice easy thing for you to see. So if my horizontal distance to an object is 3959, meaning half the radius of the earth, if we could theoretically actually see that far, which I know we can't, but this just kind of proves my math is right. So it's 3959 is the radius of the earth. So if I'm looking from the top of the earth all the way to where the edge of the earth would be 90 degrees away, looking straight across here and then that. So my sagitta, which means this line here, would be 3959 because it's the same distance this way as it is this way. Okay? So that's the same. My degree change, or my degrees, is right here would be a 90 degree. I would have 90 degrees right here. Okay? It would be a 90 degree angle from there to there. My arc length would be 6,218 miles. So my arc length is actually going to be from here looking out, go down to 90 degrees. That'd be my arc length. And then so this is my arc length in feet, or sorry, this one's feet, this one's miles. And then my chord length, meaning from there, straight line, from there to there, is going to be 5598. So my calculation of my arc length is 6218, if it's 3959. And so to double check that, to see if that's actually right, 6218 is, if you take that and times it by 4, you get 24,875. And that's what I've been using for my circumference of the Earth. And I know some people say it's 24,900. whatever. It's close enough. I've already proven in my other video, if you go back and watch it, that it doesn't matter whether you use 24,900, 24,875. If you use 1 mile difference in the radius or circumference or whatever, it's not going to make a difference on the calculations. And I've already proven that. If you want to know that, go back and watch my other video where I talk about the math of the globe. So anyway, I know that number's right, 3959. Now, this chord length number, is that one right? Is that one correct? Well, if I take 5598, if I know what a 90 degree, this is a 90 degree, I know a squared plus b squared is equal to c squared. So if I plug that formula in, I have 3959, because I'm going this way, is my radius squared times my radius squared is equal to c squared. Okay, remember, I'm talking 90 degrees, not 60 degrees right here, I understand, for my 5998. So if I take that, and I take the square root of, you can see my formula up here, square root of this, of 3959 times 3959 plus 3959 times 3959, comes up with 5998,871. So I know that that formula is correct in what I've calculated over here as my chord length. And my chord length is right here, okay? And that's how you figure out what the chord length is by doing the SAS triangle. So I know that's all right. I know my degree change is right, because if I know what my chord length is, I now know what A is because I've figured it out according to this. I know C, B, and A. I can figure out what my degree is just to make sure that it's correct. If I take that formula here, cosine A, blah, 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 I can figure out what this degree is. And so that's what that formula is there. It gives me 90 degrees. So I know I'm doing this all right. I know my calculations are right. And so we have a difference of 619 miles when we're going from, the top halfway across the Earth at 90-degree angle. So now that brings me to if we can actually look at a close distance that we can actually see. So what I've been using in my calculations here, from looking for my points 100 miles out or 130 miles out, I've been able to see 137 miles out, and I've had comments, well, you're not using the actual straight line number or a curved number, and so you need to figure out what that is, and it's going to be different. And so I want to say, well, how different is it going to be? So if we take this and we say, I've already proven that these numbers are right. Okay, they're all formulas, they're not just numbers. And actually these are just equals because they're over here. So the formulas that are over here, these are different formulas to get these things. So I just put this over here in a nice easy thing to read. So now if we say, okay, I'm using my Salt Lake, looking across the Great Salt Lake, which is 100 miles. And what we can see is Skeeta should be 6,669 feet. Which, if you remember, that's why I say I shouldn't be able to see that mountain, because it should be below my horizon. But anyway, my degree, meaning this degree change right here, is 1.44 degrees, because every degree is 69.09. 69.1 miles is 1 degree of change in the Earth's circumference and stuff. So now my arc length is 100 miles. 0.016. My chord length is 100. So the difference is 0.003 miles or 14 feet. So what that tells me is 14 feet, when you're looking at something that's 100 miles away, your difference in the chord length versus the arc length is 14 feet at 100 miles. So the people who say you need to use one or the other, or say you're using the wrong one, all I got to say is it doesn't matter. You can't tell a difference between 14 feet at 100 miles. Now, if you're looking at something closer, some people have been using other things closer, say 50 feet. Well, now it's one foot difference. Almost 2 feet. 1.75 feet difference. Now, if I'm looking 6 miles, some people say, okay, I'm just using 6 miles, and, well, you got to take that. It's literally no difference. There is no difference in it out to 2 decimal places. I guess if we can go out more decimal places, Let's see what the difference is. Okay, now we got a 0.003 feet difference. So if we convert that to inches, let's see how many inches that is. If we take that, not plus, sorry, equals that times 12, that's 0.03 inches. So it's really nothing at 6 miles. So let's go back to 30 miles. Now we're talking 4 inches. This is inches. Okay, we're talking 4 inches difference. There's no difference is what I'm saying. Now I would say, okay, we're going with 130 miles. I can see 130 miles. We're talking 30 feet. 30 feet difference at 130 miles. Even if I can see 200 miles, which is very abnormal to be able to see that far, because of our atmosphere, crap in the air, which makes you not be able to see that far. Now we're talking 112 feet. If anybody thinks they can see 112 feet difference looking across something 200 miles, I'd like to see that, because it's not possible. So the whole purpose of this video is just to say, it doesn't matter if you're using 130 miles or 130 miles minus 14 feet. It's the same number. It comes up to be the same. Don't have to worry about it. So that's all I wanted to say. Talking about this picture again. This picture is 127 miles away to this mountain. You want to go back and watch my video on this video showing that I think this mountain should be down here in the picture, below this. And I talked about I was going to do a video on perspective and then what this mountain height should look like when you're that far away. I'm working on that still. I've done some calculations. If you look here, I'm doing some apparent height versus the actual size and distance of the object. And the next thing I'm going to do is actually test different objects at different distances. You can do that by using a ruler and holding it away from your arm or from your eye and doing the distance and stuff. And so I'm working on that as well. As you can see, if, from my house to a mountain, it's, the height is 6,000 feet. The height of that mountain is really only 2 inches in my ruler if I'm looking at out 32 inches away from my eye. So that's something I'm working on. Hopefully I can get that done and video put up shortly. But again, I just wanted to kind of say on this, it doesn't matter when you're looking 100 miles or 130 miles, 200 miles, you're not going to be able to see a difference in the chord length versus the arc length. And if anybody thinks I'm wrong or has another opinion on that, I would love to hear what you have to say. Again, one of these days I'll get back up to this mountain here when the snow's gone, and I can see from that point over to this point, which is 130 something miles away, and I want to test if I am looking downward at it, or if I'm looking actually perfectly straight horizontal at it, or actually a little bit up. And that coincides again with my apparent height and stuff, and what my angle, what my degree angle should be. The only problem is when you start getting out that far, those great distances, 11,000 feet is a very small degree angle change, and so you're a half a degree. So getting something that precise to be able to see that far, I don't have anybody that works in construction to give me a one of those, I don't know what they're called, those devices that you can see, it makes it horizontal and see what the thing is out there. Anyway, I'll be working on that as well. But anyway, let me know what you guys think about this, and see you next time. Thanks for watching. Bye.